Imagine a customer wandering through a network of service stations. Due to feedback loops, that customer may visit the same station multiple times. Our central question today is simple but powerful. On average, how many times does one customer visit Node I during their journey? The answer turns out to be remarkably elegant. It is the ratio of the local flow rate at Node I to the external arrival rate of the network. But let lambda denote the rate of new customers entering the network from outside, and lambda sub I the total passage rate through Node I. When feedback exists, the same customer may pass through Node I many times, so lambda sub I can be much larger than lambda. For instance, if 10 customers per second enter the network but Node I sees 40 passages per second, then each customer visits Node I on average 4 times. The derivation rests on a single conservation argument. The total visits to Node I per unit time must equal the visits per customer times the rate at which customers arrive. Written symbolically, lambda sub I equals V sub I times lambda. Solving for V sub I gives our central formula. Beautifully simple, deeply useful. Consider this 3-node network. External customers arrive at node 1 with rate 10. From node 1, half of departures go to node 3. From node 3, half go to node 2. And node 2 always returns to node 1, creating a feedback loop. So step 1. Write a flow balance equation for each node. The total flow into node I must equal lambda sub I. As node 1 receives external arrivals of 10 plus the entire flow from node 2. Node 2 receives only half of node 3's outflow, and node 3 receives half of node 1's outflow. Substituting one equation into the next, we collapse everything to a single equation in lambda 1, and so we obtain the local flow rates, 40, 10, and 20. Now we simply divide each local rate by the external rate of 10. So one customer visits node 1 4 times, node 2 once, and node 3 twice. Notice that V1 exceeds 1 minus feedback makes this not just possible, but typical. Once we know the visit counts, computing the mean total service time per customer becomes effortless. Each visit to node I contributes 1 expected service time, 1 over mu I. We weight each per visit cost by the visit count and sum across all nodes. Plugging in our visit counts and service rates, we find each contribution, then sum them. Then the total mean service time per customer is approximately 0.26 time units. To summarize, V sub I, the ratio of local to external flow, is the mean number of visits per customer. It emerges naturally from conservation of flow, and a V sub I greater than 1 is the fingerprint of a feedback loop. Whenever you need a per customer total service time, cost, energy, the V sub I are the natural weights. They are the bridge between network level flow and individual customer experience.